Welcome back to Geometry, Chapter 9, Section 6 in this book. But you don't need this book to learn about solving right triangles with trig. Yay! I really love this. This is probably my favorite part of this book. I don't know if you can tell. Alright, so we are using trig to find out the sides and the angles in a triangle. And right now they have to be right triangles. Later in Algebra 2, you will get to learn to do it without right triangles. Woo! Using law of sine and law of cosine. But that's later. Alright, so here is our example problem. We don't use x anymore for an unknown. If it's an angle, we're going to use a Greek letter theta. How smart do we sound with Greek? And that's our unknown angle. And we have a triangle right here that has one side that's 5, one that's 3, and one that's 4. And we have to label them. The longest side is always the hypotenuse. So 5 is the hypotenuse. The side that's straight across from our unknown angle is called the opposite. And it's 3. That's how long it is. And our side that's right next to the angle that's not the hypotenuse, because this is next to it too, but the other one is called the adjacent, and it's 4. And we want to know what is theta. Now last video, they had you making fractions for the relationship for like sine equals opposite over hypotenuse. And we learned how we were going to remember that was some old horse caught another horse taking oats away. And that tells us our relationships. The sine of theta is opposite over hypotenuse. The cosine of theta is adjacent over hypotenuse. And the tangent of theta is opposite over adjacent. And I told you that you don't usually just make fractions. That the point of doing this is that you can use your calculator and it will tell you what your unknown angle is. So that's what we're going to learn today. So useful. You'll use it all the time in physics and a lot of classes. Okay, so we want to find out what our angle is. And we could use any of these because we know all three sides. But I just picked the first one. The sine of theta is opposite over hypotenuse, some old horse. So what is opposite of theta is 3. And what is the hypotenuse is 5. So I have this fraction, and that's where we stopped last time. The sine of theta is 3 over 5. I'm going to show you using your calculator how to turn it into the angle. This is what you do. On your calculator, turn it on. And then you're going to go to the second button and push it, the big button up here. And then you're going to push the sine button. It looks like it says sin, but it's sine. And it will put a little -1. It'll say sine -1. That means doing the opposite, taking the inverse. Okay, now we're going to put 3/5 in this little bracket that we have here. And we can do that by just doing 3 divided by 5. And then we should do close the parentheses. And then hit enter. And it will tell you that the angle is 36.9 degrees. We know what theta is. It is all about 37 degrees. And that is so useful that we can turn sides into angles using trig in our calculator. So then, if we wanted to find out this other angle we don't know, we can use that rule that the 3 angles of a triangle add up to be 190. 190. I've been teaching all day. I'm going to start saying things wrong. Sorry about that. 180. So we can do 180 minus 36.9 minus 90, and it will tell us our unknown angle here is 53.1. Now, so this is what is called solving a triangle. If you know all the sides and all the angles, you have solved the triangle. So how we do that is sometimes we have to use Pythagorean theorem. Sometimes we only have 2 sides, and we have to get the third side by doing a squared plus b squared is c squared. If you don't know how, go watch the other video. Sometimes we have to use the 3 angles add up to be 180 to find missing ones. But as long as we're doing this chapter, we will also use some old horse called Another Horse Taking Oats Away, the barnyard drama. Alright, so here's an example. We know it's a right triangle. We have two sides, and we want to know what is our third side. Well, what we're going to do first is the Pythagorean theorem. A squared plus b squared is c squared. 2 squared plus 3 squared is c squared. 4 plus 9 is c squared. So take the square root of both sides, and c is the square root of 13. So we've done that. Now we need to know theta. So we're going to make this our theta, and it's smarter if we use the ones we're given, not the one we did. Because if we did that one wrong, we're going to miss this part of the problem too. So we have opposite and adjacent, so we need to use tangent, taking oats away. It's the one that has opposite and adjacent. So we're going to say the tangent of theta is opposite over adjacent. Opposite is 2, adjacent is 3. We're going to put it in our calculator. Second tan, get that negative 1 up there, and put this fraction in there. 2 divided by 3, enter, and we find out that theta is 33.7. 33.7. Now, to get our third angle, we can use 180 minus 90 minus 33.7, and we find out our third angle is 56.3, and we have solved the triangle. Yay, go us. All right, here's another one. This one is, we are given this triangle. Our theta is 25, our known angle. This is a right angle, and our hypotenuse is 13. And we're going to solve it, and we can do it just with knowing it's a right triangle in one angle and one side, and we can get them all. So what we're going to do first is get the other angle. 180 minus 25 minus 90 is 65. So now we've got all of our angles, and we can get our sides. We have the hypotenuse and an angle, so I decided to use sine first. I could have used cosine, but I decided to do sine. So sine of theta is some old horse, opposite over hypotenuse. The opposite is what we don't know, so I put x. The hypotenuse is 13. So why is x not alone? It's being divided by 13. What's the opposite? Multiply by 13. What I do to one side, I do to the other. And you can just type it into your calculator exactly like that. Those cancel out. 13 sine 25, and it will tell you that the opposite side is 5.5. Now we need to go back and get the adjacent. So we're going to use caught another horse. The cosine of 25 is y over 13. Why is y not alone? I used y because I had used x before. Why is y not alone? It's being divided by 13, so I'll multiply by 13. What I do to one side, I do to the other. Those cancel out. Type it like that exactly in your calculator, and you should get that the adjacent is 11.8. And we have solved that triangle. Yay! And remember, if you're not getting the right answer in your calculator, go to the mode button and make sure you're in degree. We need degree, not radians. Okay? Let's look at this one. Here we have the space shuttle. There it is flying along. And when it is 59 miles out, it's 15.7 miles up. And we want to know what angle it's flying at. So we don't have theta. We don't have hypotenuse. We have adjacent and opposite. Which of our ones have adjacent and opposite? Ding, ding, ding. It's tangent. So we want the tangent of theta is opposite over adjacent, but we're solving for the angle. So we make it, we do the opposite, which is taking the inverse, which means we do this second tangent. Do second tangent, get that little negative 1 there, and for your fraction, put 15.7 divided by 59, close the parentheses, hit enter, and you will get that theta equals 14.9 degrees. Now they didn't ask us to solve the rest of it here. Then they said the space shuttle flies on and it gets 5 miles away from the airport and its angle increases to 19. They want to know how high up in the air is it. So we have theta and we have adjacent. we need opposite. So once again, we're going to use tangent because we want opposite and we have adjacent. So the tangent of 19 is x over 5. So why is x not a line? Because it's being multiplied by 5, divided by 5. So we multiply by 5. What we do to one side, we do to the other. Put it in your calculator exactly like that, 5, 10, 19. And you will see that the space shuttle is 1.7 miles up. That's very close. Like, can you imagine the space shuttle right there, 1.7 miles above your head? It'd be very exciting. Never had it. I've seen the space shuttle launch once. We were at Disney and we were on the little boat that goes between Port Orleans and downtown Disney, which is now called Disney Springs. And the captain stopped the boat and said, "We're going to look at the sky for a minute and watch the space shuttle go up." And whoop, there it went. It was very fun. All right, come back and we'll finish this chapter strong. Keep doing it. Practice with your calculator and you will get good at trig. Math is great.